Hi, this is Nathan Tintle. In this learning goal video, we're going to talk about how to find the value of the standardized statistic from a simulation, and we'll use the St. George's Hospital example. The standardized statistic is simply another way to measure how far out the data is in the tail. The p-value is one approach, standardized statistic is another. For a single proportion like we're dealing with here, the standardized statistic is denoted with the letter z, and you compute z, the standardized statistic, by taking the value of the statistic, subtracting the mean of the null distribution, and dividing that difference by the standard deviation of the null distribution. Let's apply this to the St. George's data. The observed statistic is 0.197. 19.7% of patients at St. George's had died within 30 days of their heart transplant since 1986. The mean of the null distribution is the value of the null hypothesis parameter. That's 15%. So we take 0.197 and subtract 0.15. We divide by the standard deviation of the null distribution. This value can be found, as shown in the lower right-hand corner screen capture, by clicking Summary Statistics and looking at the standard deviation of the null distribution from the simulation. In this case, that standard deviation is about 0.019. So the value of the standardized statistic z for the St. George's Hospital data is about 2.5. A few words of caution. When you're computing the standardized statistic, make sure that you're using the same units. We recommend to use proportions. That is, put your observed statistic value, the mean of the null distribution, and the standard deviation of the null distribution in terms of proportions in all three cases. Don't mix proportions and counts. It's a common mistake where a student bounces back and forth between the two. Second, when you're finding the mean of the null distribution, you can simply use the null hypothesis parameter value. And finally, negative numbers are okay. Negative standardized statistics simply tell you that you're on the left side of the mean of the null distribution instead of the right.